Let's begin Chapter 6 on factoring. Remember to print out the corresponding lesson pages so that you can follow along and work through the problems as you're viewing the videos. In Section 6.1, our objectives are to factor out the greatest common factor and factor by grouping. Writing a polynomial as a product of two or more simpler polynomials is called factoring the polynomial. Factoring undoes or reverses the multiplying. In our previous chapter, we looked at multiplying polynomials. Beginning here with the first example, we have a monomial, that single factor, single term of 3x, multiplied by the binomial. To do that, we are multiplying by using the distributive property to get 3x times 5x, which gives us 15x squared, and 3x times minus 2, which gives us negative 6x. Now the factoring undoes or reverses the multiplying. So in this case, we're starting off with the expression 15x squared minus 6x, and we're looking for the greatest common factor, the largest factor that goes into both the first term and the second term. In this case, that factor is 3x. 3 goes into 15 and it goes into 6, so 3 is a common factor. X is also a common factor because both of those terms contain the x, so you factor out what both terms have in common. It undoes the multiplying, so essentially you're dividing. If you have 15x squared and you factor out a 3x, in other words, you divide by 3x, you get 15 divided by 3, which is 5, and x squared divided by x, which gives you x. We're doing the reverse of the multiplying. If you factor a 3x out of the 6x, essentially dividing out that 3x, 6 divided by 3 is 2, and x divided by x simplifies. So the factoring is we want to find the original monomial and binomial that is a result of multiplying. So we are dividing, we're factoring out, it undoes the multiplying. The first step in factoring is to find the greatest common factor, the GCF, the largest term that divides each term of the polynomial. The GCD, greatest common divisor, is a factor of all the terms of the polynomial. Let's factor out the greatest common factor. We're looking at the coefficients 7 and 21. The largest number that goes in both of those is 7. So the greatest common factor is a 7. And notice that the first term has an m, but the second term does not have an m. So m is not part of our greatest common factor. We are looking just to factor out what they have in common. In this case is 7. So we're undoing that distributive property. We're undoing the multiplication by dividing out. When we are factoring out a 7 from the first term, we're dividing 7m by 7, and the result is m. When we're factoring out 7 from the second term, we're dividing 21 by 7 to get 3, and because that minus sign is there, we get a minus 3. So this is written in factored form, and the greatest common factor of 7m minus 21 is 7. On this slide, we have a few more examples of factoring out the greatest common factor. We look at the coefficients and determine what is the largest number that can go into both 22 and 66 without leaving any remainders. In this case, our greatest common factor is 22. The first term has the variable c and the second term has the variable d, so there are no variable common factors. 22 is the greatest common factor. When we are factoring out 22, we are dividing each of those terms by 22. So if we divide 22c by 22, the 22's will divide out and we're left with c. If we're dividing 66d by 22, we take 66 and divide it by 22 to get 3, and that's a minus 3, and the d, it will remain. You're only factoring out the 22. You're dividing out the 22. It undoes that multiplication. The nice thing about factoring is that you can always check your work. Checking The check step here is found by multiplying. Since the factoring undoes the multiplying, when we take your answer to check, we do the distributive property multiply and see if we get our original problem. 22 times the quantity C minus 3D. We're going to use the distributive property 22 times C to get 22C. And 22 times negative 3D gives us negative 66D. And that's what we started off with. Let's look at part B. We want to find the greatest common factor of 9Q and 17R. In this case, the greatest common factor is only 1. There is no other number that goes into both 9 and 17 without leaving any remainder. There is no common variable factor. The first term has the variable q and the second term has the variable r. So we say that this cannot be factored. We're looking for a greatest common factor other than 1. Another thing that we can call this polynomial is that this is prime. Prime means that it cannot be factored. Let's look at part C. Here we have 3 terms. We have a trinomial. We want to find the greatest common factor, the largest number that goes into all 3 of those terms, as well as the largest variable that goes into all 3 of those. Notice that the coefficients 8, minus 8, and plus 48 can all be factored, have a common factor of 8. So that is part of our greatest common factor. Now also notice that they all have variables. The same variable, in fact, a cubed, a squared, and a. They all have a common factor of a. When your greatest common factor includes a variable, it's always the variable with the smallest exponent. So our last term has an a term, and that's a to the first power. So whatever the smallest exponent is, that's going to be part of your greatest common factor as long as all of the terms contain that variable. So we are going to factor out 8a from each of those terms. We are essentially undoing the multiplication process. Think of it as division. We divide each of these by 8a when we're factoring it out in front. So the 8 divided by 8 is 1, and then the a cubed divided by an a, think of that as a to the third divided by a to the first power. So when you subtract the exponents, you get a squared. Now you can do a quick check here. If you were to multiply 8a times a squared, the result would be 8a cubed. For the second term in the parentheses, we're dividing the minus 8 by positive 8, and that's going to give us a minus 1, or minus a in this case, because we're also dividing a squared by a, an a to the first, and that will give us a single a. The last term, we're factoring out an 8a, so 48a divided by that common factor of 8a is 48 divided by 8, which is 6. And the a divided by the a greatest common factor will cancel out. Now our factored form is written here, where we have the greatest common factor 8a as the monomial out in front, and then the result of factoring that out is your trinomial a squared minus a plus 6. Now in this example, the first one, x times the quantity a plus b plus y times the quantity a plus b, also has the greatest common factor. However, if we look at this, we've got a very large first term here. Think of this entire expression here, x times the quantity a plus b as the first term, and y times the quantity a plus b as the second term. So the greatest common factor is what they both have in common. The first term has an x, but the second term doesn't. That's not part of the GCF. The first term has a plus b, and the second term also has a plus b. So the greatest common factor of both of those terms is a plus b. The second term has a y in it, but the first term doesn't have a y in it, so that's not going to be part of our greatest common factor. Now we can write the greatest common factor is a plus b, and we're taking it out of both of these terms. Take the entire first term and factor out the a plus b. The a plus b's will divide out, and you'll be left with x. Factor that out of the entire second term as well. Take an a plus b factor out of y times a plus b, and the a plus b's will divide out, and you'll be left with y. So in factored form, we have one factor of a plus b, and the other factor is x plus y. Let's look at this second example on the page. Find the greatest common factor. The first term has, looking at the coefficients of 3 and 2, there is no other greatest common factor other than 1. So let's move on to the variables a. They both have that variable a, so that's going to be part of the greatest common factor. And notice they both have the b minus c expression. The first one has a power of 2, and the second one has a power of 3. So the greatest common factor will have a b minus c factor, and using the smallest of those exponents, the second power. Now we can factor that common factor of a times b minus c squared out of both of those terms. Now, if we factor out of the first term here, the a's will divide out, and we'll have 3. The b minus c to the second power will divide out with this b minus c to the second power. So the first term inside the parentheses here is 3. The second term, we're dividing all of this by entire quantity, dividing out the a and b minus c squared. The a will divide out, but you will be left with that plus 2. And this b minus c to the third power is factored out a b minus c to the second power. So the result will be left a b minus c to the first power. So this is one way that you can write your answer in factored form. There's one other thing that we can do here is if we have we can distribute the 2 here, and that'll give us 2 times b minus c to the second times 3 plus 2b minus 2c. So this is an alternate way of writing the expression in factored form. Factoring out a negative common factor. When the coefficient of the term of greatest degree is negative, it is sometimes preferable to factor out the -1. That is understood along with the GCF. So our first coefficient here is negative. So part of our greatest common factor is negative. Now we look at the coefficients, the 3, the 9, and the 15. Notice these are all multiples of 3, so 3 is a common factor. In terms of the variables w, not all of the terms have a w in it, so w is not going to be part of our greatest common factor. So let's look at the result of factoring out that -3. We're taking each one of these terms and dividing it out a -3 that we're pulling out in front. So the -3 divided by the -3 here is a positive, and the w to the 4th. And the second term, 9w cubed, factoring out a -3, 9 divided by -3 is -3, w to the 3rd. And then the last term, -15, dividing out a -3, gives us a positive 5. So this will be our answer in factored form. So again, when the coefficient of the term of the greatest degree is that highest exponent, is negative, it is sometimes preferable to factor out the -1. That is understood along with the greatest common factor. Factoring by grouping. Many polynomials have no greatest common factor other than the number 1. Some of these can be factored using the distributive property if those terms with a common factor are grouped together. Consider this polynomial. In terms of looking at all 4 of these terms, the first has a 5, but only the second has a 5. The last 2 terms don't have 5s. The third term has an x in it, but the fourth term has an x in it, and the first term, but they don't all have an x in it. So what we could do here is factor by grouping, looking at the first two terms as one group and looking at the last two terms as another group. Now, out of the first two terms, the GCF just for these two, GCF is 5. The GCF for the last two terms is x. So by grouping, we're going to factor out the greatest common factor from each of those groups. For the first one, we're going to factor out a 5. And if you factor out a 5 from the first two terms, the result, what you'll have left, is x plus y. For the last two terms, we're going to factor out the greatest common factor of x. And whatever sign this is, that's the sign of what you're going to factor out. So we're going to factor out a plus x from those last two terms. And the result is going to be x. When you take the x squared divided by x, you get x. And the xy, factor out the x, you get a y. Now look at these two larger groups. We have the first large group is 5 times the factor x plus y, and the second large group is plus x times the factor x plus y. The greatest common factor of these two groups is x plus y. So that's what we'll take out in the next step. Take out that common factor of x plus y, and then what you have left, after you take out x plus y out of the first term, the 5 is the only thing left. And after you take out an x plus y from the last two terms, the only thing you'll have left is plus x. So this would be our answer in factored form, and that's the method of factoring by grouping. Typically, when you have 4 terms in your expressions, one approach would be to use the factoring by grouping method. See what the first two factors have in common and what the last two factors have in common. So factor by grouping, you can use the following 3 steps. Step number 1 is group the terms. Collect the terms into groups so that each group has a common factor. Step number 2, factor within the groups. Factor out the common factor in each group. Step number 3, factor the entire polynomial. If each group now has a common factor, factor it out. If not, try a different grouping. Always check the factored form by multiplying. Let's take a look at this example. Factor ax minus by plus ay minus bx. As you can see, there is no greatest common factor for all 4 of those terms. But if you group them in a way, it is possible to determine, find greatest common factors within each group. Let's do a little bit of rearranging first. The first term is ax. Now, the second term has nothing in common with it. So I'm going to write the third term next. So I'm going to group the ax and the ay together because they both have a common factor of a. And then I'll write the last 2 terms, the minus by with the minus bx. And notice that they both have that minus b as a common factor. So we are going to factor out of the first 2 terms, the first group, they both have that a factor. So if you factor out the a, you'll be left with x plus y. Now, the last 2 terms has a common factor of minus b. So again, whatever that sign is that's separating the 2 groups, that's the sign that you're going to factor out. You're going to factor out a negative b. And what you have left with is when you factor out the negative b, you'll end up with a positive y here, and factor out the negative b here, you'll end up with a positive x. So now looking at these 2 larger groups, the first group and the second group, notice that they do have a common factor of x plus y. So x plus y is one factor, and then the other factor is if you take the x plus y out of this group, you'll be left with an a, and take the x plus y or y plus x out of the second group, you're left with a minus b. So this is our final answer in factored form. All right, in this example, we want to factor by grouping as well. Now let's see, if we look at the first two terms listed here, we do see that they both have a common factor of y, in fact y to the sixth. And looking at the last two terms, they both have a common factor of y, the smallest exponent being 4. So we'll factor out, of the first two terms, we're going to factor out a y to the sixth. And out of the last two terms, we'll factor out a y to the fourth power. Again, you're factoring out that smallest exponent within each group. When you factor out a y to the sixth from y to the seventh divided by y to the sixth is y to the first. You're left with a single y. And then the second term, y to the sixth z, divide out a y to the sixth, you'll be left with a minus z. For the third term, the y to the fifth, factor out a y to the fourth, you're left with a single y. And a minus y to the fourth z, factored out a y to the fourth, you'll be left with a minus z. Now looking at these two larger groups, you'll see that they both have that common factor of y minus z. And then the other factor, when you take the y minus z out of the first group, you're left with y to the sixth, and take the y to the, y minus z out of the second term, you're left with a y to the fourth. Now you could even go further with this. Notice in this second group, they both have that y term. So there is a greatest common factor that you can take out of the last two terms. So we can write this as y minus z is one factor, and what they have in common here, since they both have that common factor of y to the fourth, you can factor out, and the result here, y to the sixth divide out a y to the fourth, you get y squared, and y to the fourth divide out y to the fourth, you get 1. So this is one way that you can write your final answer in factored form. This would be completely factored. The order in which those factors appear are fine. It's fine to rearrange those. Multiplication is commutative, so the order in which they appear does not matter.